It's been a rough day, okay?
It's been a rough day.
It's been a long day. I'm really tired. I don't know.
Mr. Howard was getting out and sorry that I was.
Whatever you take notes on, and that blank periodic table.
I have another good thing.
What's your other good thing?
My friend from Idaho is pulling up.
Ooh, nice. I like that. I need a piece of paper. This will work. This will work. Okay. I have an immense amount of writing to do. Like for me, you guys, it's not gonna feel like that much, but it's gonna work better if I do this on the document camera. What we're doing today. All right. So today we are doing some quantum stuff. So you can entitle today's notes "Quantum Stuff." Quantum stuff. So, you guys remember watching the video with the old guy?
Oh, yeah.
Yes? Talking a lot about quantum levels and talking about exciting electrons, yes? Did you see how he burned different chemicals, they're different colors?
Yeah.
We're doing that next chapter. It's going to be really cool, all right? Really cool. Did you miss the day we watched the movie?
Yeah.
It's fine. Fine. So here is what we know. We know that so far we've learned a Bohr model, right? And our Bohr model has how many electrons in the first level? Two. How many in the second level? Third level. Last level? Two. This only works up to what element?
The last one?
No. Calcium, right? Because calcium has how many electrons? 20. So this makes it look like we can't do anything past our calcium. But guess what? Do other elements past calcium have electrons?
Yeah.
They sure do. So we have to come up with a way to organize them. Other ways we've organized them would be something like this, a Lewis dot structure, right? Lewis dot structure for bromine. I could do that, right? How many dots would bromine have?
What group is going?
It's in group 17. It has 7 dots, right? 1, 2, 3, 4, 5, 6, 7. Sulfur would have how many? 6. 1, 2, 3, 4, 5, 6. Hydrogen would have how many? 1. Okay. So that's one way that we could do that. What about everything else? So what you guys don't know is there's actually sublevels of electrons. There are 4 sublevels. I will tell you that about the next 10 minutes aren't going to make a lot of sense, but when we put it together at the end of the 10 minutes, it'll make more sense. So will you stay with me for 10 minutes? Okay. The first sublevel is the S sublevel. Is the S sublevel. And the S orbital looks like kind of like a spear. All right, do you see how that's 3D? How I kind of made that look 3D? You guys see that? Yeah. The second sublevel is called the P orbital. So the P orbital looks kind of like this, like dumbbells. Like if you were like lifting dumbbells.
Yeah, that's not quite.
Well, it is.
It's like a mask.
The third one is the D orbital. This gets crazy. So I've got like one like this. I've got one kind of like this. And then I've got one like kind of coming out of the screen, that dot. You see how that's 3D? Yeah, there's like one like, this can either be going out of the screen or like coming into the back of the paper, however you guys want it to be. And then there is the F. And for the F, no one really knows what that looks like. All right? So question mark. So I've got 4, all you have to know is I got 4 sublevels and I got 4 orbitals. Now, this D orbital looks really 3D. Did you guys make it so there's like dots coming off one of them? Yeah. All right, so everyone look at it like either at the screen or at the paper and just blink really fast and it'll look like it's like 3D. I'm just kidding. You guys look ridiculous right now. I just want you guys to do that. That was very satisfying. You guys all look like this. That's good. All right.
I
So
was expecting it to like start spinning.
each individual orbital only holds, any guesses of how many electrons? 2 electrons. Only holds 2 electrons. So if I have an s orbital, how many can it hold? A d orbital, an f orbital, a p orbital, 2. You got it. So how do these build? How do these build? So skip a few lines. For n equals 1, the first quantum level, I have 1 s orbital. I have 1 s orbital. How many electrons can I fit in 1 orbital? 2. 2 electrons. For n equals 2, I have, look how weird this looks, 3 p orbitals. 3 p orbitals. If I have 3 p orbitals, how many electrons can those hold? 6 electrons. For n equals 3, any guess what letter this is going to be? D. Any guess how many orbitals? There's a pattern here. 5, yes. 1, 2, 3, 4, 5. There are 5 d orbitals. 5 times 2 is 10 electrons. Everybody with me so far? And then finally, n equals 4. Any guess how many orbitals? 7. And these are going to be what letter? 4, 5. Yes. F, 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 F. So I have 7 f orbitals. 7 times 2 is 14 electrons. So what are we doing? You may be asking. Great question. All right, great question. So these are the orbitals. And what we're going to notice is these orbitals are going to match up with some kind of pattern over here on this beautiful table of elements. On this beautiful table of elements. So how do these fill? Kind of like this. So first one I would write 1s. Write this on your paper exactly how I write it. First level has 1s orbital. Second level has a 2s and a 2p. Guess what the third level has? A 3s, a 3p, and a 3d. Do you see how each quantum level is increasing by 1 sublevel? Yes. Fourth level, 4s, 4p, 4d, 4f. Are you guys making this look exactly how I'm drawing it? Fifth level, 5s, 5p, 5d, 5f. What the 5g? What? Have I said anything about a g orbital yet? No. But this is how cell phones work. No, I'm kidding. I'm kidding. All right? That was like 5G.
I get it.
Yeah. No. 5G is imaginary. All right, it's imaginary. May we need 5G later?
Yeah.
When?
Whenever you tell us.
When we discover more elements. All right? We may need 5G eventually, but as of now, we don't think it exists.
You think we'll ever go to 5G?
I don't think so.
Or no, it wouldn't be.
I don't think so. I don't think so. Then I have 6s, 6p, 6d, 6f, 6g, 6h. So G and H are imaginary. That's why I'm putting them in parentheses. And lastly, 7s, 7p, 7d, 7f, 7g, 7h, 7i. And now you're really thinking, Heller, what the heck are we doing? All right? Are we thinking that? Yeah, probably thinking that. So each quantum level has one more sublevel. And the sublevels are consisted of different what? Types of orbitals, right? Different types of orbitals. Now, the question is, how do these orbitals fill? This is where it gets really weird. Because you would think it would just go here, 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 here. That's not how it works. The orbitals always fill down and to the left. Draw that.
Does it have to go through the 1s?
Just like I did. So, s orbitals hold how many electrons?
2.
2. Do you have a blank periodic table? So, how many elements do I have in the first row? Ah, there must be some kind of relation here. So stay with me. Stay with me. So I would write, I know, the looks on your faces are what I would expect. It's all good. I would write 1s1 and then 1s2. Each one of these boxes represents 1 electron. Okay? So I don't want to think of these as elements anymore. Think of this as like a game board of electrons. Okay? S has how many electrons? 2. 1 electron here, 2nd electron here. You with me so far? Stay with me then. Stay with me. Then I'm going to fill my 2s. Well, check it out. How many atoms, how many spots do I have right here? 2. So I'm going to have, I would fill my 2s1 first, then my 2s2. This is more in depth. This is more in depth electron chemistry. We're doing a little mini unit that's a little bit more in depth than what we need to do. But you're going to get it. By the end of today, you'll get it. What? I just did this in AP chemistry actually a week ago.
Wait, is there a test over this?
But it's way more involved than this. Over this, we'll have a little quiz. But by the time we get to it, you'll ace it. You will. I believe in my ability and your ability to learn this. Stay with me. Stay with me. I promise. Now, here's the cool thing. What fills next? 2p and then what? 3s. Now, how many p orbitals are there? 3. How many can that hold? Oh, snap. How many are in this part of the periodic table? It's kind of cool. So this would be 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. After my 2p's, I fill my 3s1, 3s2. Do you see a pattern starting to form over in this area of the periodic table?
Not really.
You don't? These are all what type of orbitals? S. These are all s orbitals. Any guess of what this block's going to be? Ah, okay, you're getting it. I could have just shown this to you and not explained it, but I'm trying to actually explain it. Stay with me. Okay? Yes? Two what? Each orbital holds 2 electrons.
But then why are there 6?
Because this is 1p orbital, that's 2p orbitals, and that's 3p orbitals. The 3p orbitals can hold a total of 6 electrons.
In N2, there's 3 P's.
He's right.
P, there's 2 E's.
That's actually good. Yeah.
What?
What I'm saying is I've got 3p orbitals, right? 3 times 2 is 6, which is 6 electrons. This would be my first p orbital, my second p orbital, my third p orbital. Okay?
No, I have to do.
Good. Okay, stay with me. Promise. After my 2p, 3s, next thing I fill is my 3p and then my 4s. We're not there yet. 3p1, 3p2, 3p3, 3p4, 3p5, 3p6, and then 4s1, 4s2. Are we all together so far?
Not really.
Are you at least caught up with me? No chemists left behind here. No chemists left behind. Okay. What do I fill after my 4s? No. 3d, 4p, 5s. Now, how many d orbitals are there? There's 5 d orbitals. 5 times 2 is, guess how many elements I have in this area of the periodic table? Ah, it's all related. So this would be 3d1, 3d2, 3d3, 3d4, 3d5, 3d6, 7, 3d8, 3d9, 3d10. And then after my 3ds, I fill 4p's. So back up to 4p1, 4p2, 4p3, 4p4, 4p5, 4p6. And after 4p's, I have my 5s's, 5s1, 5s2. I think this is super cool when you actually like start to understand this, that like, oh, this is another layer of a pattern on the periodic table. So this tells us exactly where electrons go.
Yeah, that's
5s1, 5s2. 4p1, 4p2, 4p3, 5s1, 5s2.
Oh, where are the F's going to come?
Great question. Soon. Soon. All right. After my 5s, I fill 4d, 5p, 6s. So I'm going to go to my 41. You kind of say it like a 4d2, 4d3, 4d4, 4d5, 4d6. Sounds like I'm saying 40. 47, 48, 49, 4010. That does sound like something Mater would say. Up to my 5p's. 5p1, 5p2, 5p3, 5p4, 5p5, 5p6, 6s1, 6s2. You guys now see why I did not do this on the big screen. 5p1, 5p2, 5p3, 5p4, 5p5, 5p6, 6s1, 6s2. So if you are keeping track on the regular periodic table, I am at barium. Agreed? Yes? So after barium, what technically belongs here?
Lalu.
Lalu. Guess how many elements are down here? 14. So, what do I fill after my 6s? 4f, 5d, 6p, 7s. So after I fill my 6s's, I then come down here to my 4f's. 4f1, 4f2, 4f3, 4f4, 4f5, 4f6, 4f7. I'm glad I don't have to do this one time today. After my 4f14s, I go back up to my 5ds.
I skipped 3.
That's unfortunate.
Oh, my hand hurt. I need to go left and right.
Then my 6p's, 6p1, 6p2, 6p3, 6p4, 6p5, 6p6, 7s1, 7s2. That's where we've got so far. Where we're at so far. I don't see a lot of fall colors. Sarah Beth has fall colors
Is
on.
that SD?
Where?
Wait, like, not the 6, S2, what's 5?
5d1, 5d2, 5d3, 5d4. Like I said, this takes a little bit longer. I could have just thrown it at you and it would have made even less sense, I promise. 7s1, 7s2. It's a pattern. So what would you call this block of my periodic table? The S block. That's the S block.
Hold up, we're nowhere near there yet.
I'll pause.
After the 5D, like,
6p's, 6p1, 6p2, 6p3, 6p4. Following the pattern.
So wait, what is this?
I'm going to show you in a second. This does not make any sense at all yet until I show you. We got to finish this first.
Stay with me.
Stay with me. I told you about 10 minutes of confusion.
I think it's been past 10 minutes.
It might happen. Around 10. Okay.
It's definitely been like
Yeah, but we didn't start this right at the beginning. The last orbitals I have to fill, 5f, 6d, 7p. So after 7s, I go down here to my 5f.
5F.
Yep.
I'm at 5.
5f2, f3, 5f4. You guys got it. I'm not going to say it out loud.
Same.
After my 5Fs, I go back up here to my 60s. 61, 62, 63, 64. I'm done. 65, 66, 67, 68. And then finally my 7Ps. 7P1, 7P2, 7P3, 7P4, 7P5, 7P6. I'm done. I will hydrate while you guys catch up. I know, it's a lot of work. A lot of work. Nigel, how is Annie going? You guys are practicing with the pit now?
Shout out to Block.
Shout out Joe French.
Shout
Oh,
out.
Joe French is gonna be in the pit.
Nice.
What are you doing with it?
Play. It's live music.
Shuffle up.
Ooh.
Shout out to Block.
He's good though. He's really good. All right, you guys got it?
Is that one the S block?
This is the S block. Guess what the block in the middle is called? The D block. Now, what do you notice about D's compared to S's?
There's more?
After 4S, I go to my 3D. After 5S, I go to my 4D. So what would you say about D's? D's trail by 1. D's trail by 1. What about my F's? I go from 6S to 4F. I go from 7S to 5F. My F's trail by? Yes. So my F's trail by 2. This is my F block down here. And then over here, what's this block going to be? My P block. So I have an S, a P, a D, and an F block. Are we good on where these are on the periodic table?
Is the 1S2?
F's trail by 2 because I go from 6S to 4F and then 7S to 5F.
Is 1S2 an S block?
S2 is technically an S block, but we know that it doesn't go there because it's a noble gas, right? So over here in the periodic table, we know these are going to be what? S's, these are, and these are F's. You got it. Okay. What do we do with this? What'd you say? P's don't trail. Because S's and P's are both 2. So 2, 2, 3, 3, 4, 4, 5, 5. So P's don't trail. D's trail by 1, F's trail by 2. What do we do with this? What we do with this is called an electron configuration. An electron configuration. So, if I asked you to write the electron configuration for hydrogen, you're right. Hydrogen has a total of how many electrons? 1. So how many blocks would I have to fill? 1. So hydrogen, the electron configuration would be 1s1. 1s1. Pause. Don't get ahead of me. What if I asked for the electron configuration for helium? Helium, do I have to fill this block with an electron? Yeah. Do I have to also fill this one? Yeah. So I'm filling both of my 1s's. So helium would be 1s2. How many electrons does helium have? 2. What does this number add up to? What's 2 plus 0? 2. Try something a little more complicated. Let's look at, I don't know, oxygen. Oxygen has how many total electrons? 8. Has 8 electrons. So back to my game board. How many boxes do I have to fill? The first 8. Do I need both of my 1s's? Yes? So I would write 1s2. That's saying I filled both of my 1s's. After my 1s's, Where do I go next? Do I need both of my 2 S's? I sure do. So then I would write 2s2.
2p4.
And how many of my 2 P's would I have to fill? 4. I would have to fill 2p4. What is 2 plus 2 plus 4? How many electrons does oxygen have? 8. Now, if you want me to really blow your mind, all right, let's do one more. Let's do, what? No, let me pick it.
Can we do JK?
What? No, we're not doing JK. Argon? No. Let's pause first. Take a look at this. What is the highest energy level in oxygen, 1 or 2? 2. So you would agree that these are my highest energy level electrons? Yep. Would you agree that those are also my outermost electrons? Yep. What is 2 plus 4? 6. How many valence electrons does oxygen have? 6. Oh, snap. So you can also figure out valence electrons from electron configurations as well. It's really cool when you start to actually understand it. Let's do iron. You want to try it on your own?
Yeah.
Try it on your own. You can check your answer. You'll know if you get it right. You will know if you get it right. Fe is number 26.
All right, here we go.
On your own. You can always check your answer. Because you know the little superscripts should add up to its atomic number. You guys have a periodic table of your own, right? Iron's 26.
Guys, how much?
4, 10, 12, 18, 26.
Then you got it right.
Oh, dude, I don't want to.
Oh, snap.
You're just saying what orbitals have you filled? JT, you got it?
JT12.
I got it.
Dog, bro.
Say what the fuck? This makes more sense than what we just did in science class.
We never knew that until we could do this.
I think I got it.
You got it? I'll wait 30 more seconds.
This makes more sense than what we just did.
Because I taught you all. Because I actually showed you why.
You can say I got it right.
You're supposed to.
Here's the thing. You know if you got it right. If your superscripts add up to 26, you did it correctly. Yes? So here we go. Did I need both of my... I'm trying to get to here, right? Yes? Essentially, don't do that in yours, okay? 1s2. Then I had 2s2. Did I need all my 2p's? 2p6. Did I need all my 3s's? Did I need all my 3p's? 3p6. Both of my 4s's, 4s2. And how did I end? 3d6. 3d6. So, if I asked you before this, how many valence electrons does iron have? Would you have been able to tell me? No. No, because remember, these change. If I look at my electron configuration, what is my highest energy level? 4. So how many valence electrons does iron have? 2.
Wait, what?
There's 2. It's the highest energy level. Highest energy level. Okay? Are you ready for the hardest one you'd ever have to do?
Is it gonna UUO?
Let's do. I'm going to put it down here. Mercury. Number 80. I don't know.
It's so big, bro. Look at that.
Couldn't get harder than this.
It's all the way at the bottom.
Try Mercury.
Where is it?
Number 80.
Same star as the other.
It's very repetitive. It's very repetitive.
What, there's like 6 in all
No.
HG is number 80. Very repetitive.
Wait,
80.
Oh,
Oh, wait, it's just 60, 10. Yeah.
five.
Two valves left. 54.
I got 54.
Pause. You okay?
2 valve electrons.
Yes, sir. I agree. Wait, is it also static? And how it's
You'll see. So, I could have showed you over here S, D, P, F, right? 1S2, 2S2, 2P, 6, 3S, 3P, 4S. After my 4S's, I go to my 3D, 4P, 5S. Do you see how you don't even need this sheet?
Yep.
Right? You don't really need that as long as you know that there's S's, D's trailed by 1, right? F's trailed by 2. Okay. You won't get to use that in the quiz, but you'll be fine. Okay.
We don't get to use this.
No, you won't need it. Seriously, you won't need it. You really don't need it. So here we go. Let's write all that down. 1S2, 2S2, 2P6. No, it's not. 3S2, 3P6, 4S2. How are you guys doing so far? 3D10, D's trailed by 1, right? 4P6, 5S2, 4010, 5P6. Pause. After 6S2, where do you have to go? That's why it wasn't adding up for some of you. A lot of you were probably 14 short. All right?
I was none short.
After 6S2, 4F14. And after 4F14, then what do I need? 5D10. That will add up to 80.
Yeah, see, I think we should. Wait, what about 5F?
What? If you'd have to go farther for that.
Oh, yeah, you're right.
What if I gave you this? If I said 1S2, 2S2, 2P6, 3S1, could you tell me what element that is?
Yeah, it has 3 valves left.
Could you tell me what element this is?
Sodium.
Yeah, that's super easy, right?
How'd you pick the last one?
Well, first of all, I'm ending at 3S1. Second of all, 2 plus 2 plus 6 plus 1, NA. So you go the either way on that. Look at the back of that thing you just wrote all those things on.
Oh, no.
That's your homework. Yeah, you guys got it. No. You guys have 8 minutes. Get that done.